The practice of structural parameter testing is paramount for categorizing running shoes accurately and for providing evidence-based information to the consumers. The lack of structural parameter testing has led to a lot of misinformation for the consumers. And I'm going to give you an example. Recently, a website, runnerrepeat.com, categorized two shoes as being similar and motion control shoes. And through our structural parameter testing, we found otherwise. The two shoes that they said were similar was the Brooks Beast, which weighs about 11.6 ounces without the insole and has a 12 millimeter heel to toe drop. And it compared that to the Skechers Go Run Forza 3, which weighed about 8.7 ounces without its insole and had a 6 millimeter heel to toe drop. It said these are both motion control shoes and they're very similar in function. So what we're going to do is we're going to test both these shoes and see what the difference is. So we've already had the data for the Brooks Beast here in this left side column, just for saving time. On the right hand column, we will be testing the Skechers Go Run Forza 3, and we'll compare the difference in all the structural parameters. So the first test we're going to do is we're going to test the midfoot stability, and the way we do that is we twist the shoe on this long axis 15 degrees. We measure the resistance to that in inch pounds. The more inch pounds, the more stable. The less inch pounds, the less stable. So let's go ahead with this. So we have about 36 inch pounds. So let's place that into our calculator. Okay. So the next thing we're going to do is we're going to test the rear foot stability. We're going to compress the shoe 100 pounds. The more distance it takes to get to that 100 pounds, the less stable, the softer the midsole. The less distance it takes, the firmer the midsole, the more the stability. We're going to compress the shoe to 100 pounds. And we've got 6.14 millimeters. So we'll place that into our calculator. Okay. And then the last thing we're going to do is we're going to test the energy rebound in the shoe. So we'll compress this to 100 pounds. We'll release this lever. This travels upward, and that will give us the rebound index in millimeters. So let's go ahead with that. And we have 10.92 millimeters. So let's place that into our calculator. Good. So we have all our data. We have the Brooks Beast on this side. We have the Skechers on this side. So if we take a look at this, the weight difference is the Skechers is 25% less weight than the Brooks Beast. The midfoot stability, it has 45.45% less midfoot stability. The hindfoot stability, the Skechers has 28.72% less hindfoot stability. The vertical support, it has 101% less vertical support than the Brooks Beast. And the overall stability, it is has 36.9% less overall stability. The shoe stability index for the Brooks Beast is 78.9. That for the Skechers is 49.7. So if we take a look at that on our schedule of over 40 pairs of shoes that we just tested, the Skechers is 49.7. So it would be in the minimal stability area on the schedule. And that would mean people of small to medium stature, 160 pounds or so, with the neutral foot pattern would best fit into this category. The Brooks Beast is way up here, and it's in the high stability, and it's in the motion control area of the spectrum. And the person that can be in the Brooks Beast is a moderate to severe pronator or a supinator. So they're totally different shoes, and that's where we don't agree with the runnerrepeat.com website. One is a minimal stability shoe, the other is a high stability motion control shoe. So this tells you that it's very important that the practice of structural parameter testing is involved in categorizing shoes. We hope you appreciate this.